Okay, now we are going to look at writing and simplifying expressions from word problems.
This starts on page 387 of your textbook, and that's where you will find this situation. Patricia, Hugo, and Son work at a music store. Each week, Patricia works 3 more than twice the number of hours that Hugo works. Son works 2 less hours than Hugo. What we want to do is try to write an algebraic expression where we can figure out how many hours they all work together. It says at number 1 here, let X represent the number of hours that Hugo works each week. If you go back to the original problem, it says Patricia works 3 more than twice the number of hours that Hugo works. So Patricia is being compared to what Hugo works. If you go to the next sentence, Son works 2 less hours than Hugo. And again, Son is being compared to Hugo. So Hugo is that person that the other two are being compared to. That's why we're letting X equal Hugo. So what I would like for you to do is write page 387, number 1, X equals Hugo. It's hours, Hugo's hours. Then we can go back to our original sentence and figure out what to do for the other two, comparing them to Hugo. It says, Patricia works 3 more than twice the number of hours that Hugo works. That's pretty complicated. So let's go to the next one and see if it's a little bit easier. Son works 2 less hours than Hugo. How can we show 2 less hours than Hugo? If Hugo works X hours, then X minus 2 would be the number of hours that Son works, because she works 2 less hours. So these are Son's hours. Then let's go back to Patricia. Patricia works 3 more than twice the number of hours that Hugo works. Let's work that sentence backwards and go to this part first. Twice the number of hours that Hugo works. How can I show twice the number of hours that Hugo works? 2 times X, because X is what Hugo works. 2 times that would be twice that amount. And then we need to go back to our sentence and go, okay, Patricia works 3 more than that. So 3 more than that. How do I show 3 more? I add 3. So Patricia's hours can be represented by 2x plus 3. Twice the number of hours Hugo works plus 3 more. So Patricia's hours. Here it says model the total number of hours that Patricia and Son work. Draw the results below. So looking only at Patricia and Son, we could write their 2 numbers of hours together. So we could say 2x plus 3, that's Patricia's hours, plus x minus 3. It says like tiles are tiles that have the same shape. Group like tiles together and remove the 0 pairs. Draw the results below, then write the expression for your drawing. Well, since we didn't draw out what we have here, we're just going to talk about what would be alike. Well, 2x and 1x would be alike. So we could actually put those 2 things together. If this is 2 x's and that's 1x, how many x's would that be? That would be 3 x's. Then we have this positive 3 and this negative 3. When it talks about removing 0 pairs, if you think back to when we used number counters way back at the beginning of the year, we represented positive 3 with 3 pluses, and we represented negative 3 with 3 negatives, and we can match up positives and negatives. What's 3 minus 3? It's 0. So we're not going to have to add anything to this 3x. We just have 3x as our expression. The cost of a jacket, this is example 4 on page 389. The cost of a jacket, J, after a 5% markup can be represented by the expression J plus 0 and 5/100 times J. Simplify the expression. Then determine the total cost of the jacket after the markup if the original price of the jacket is $35. So J equals the cost of the jacket. So, and we know that J, that's a semicolon by the way, and that's a J. J equals $35 because it tells us that later in the problem. It says there's a 5% markup and it can be represented by the expression J plus 0.05 J. We're going to learn later in the year when we do percents that 0.05 is the same as 5%. So that's why this expression works, because that's 5%. So we're going to write down our expression, J plus 0.05 J. And now we want to combine our like terms. So we can see, whoops, I got to put the plus sign in there. I'm going to rewrite that because I messed it up. J plus 0.05 J. We can see that J and positive 0.05 J are like terms. Remember that there is an imaginary coefficient of 1 right there in front of the J. So we want to add 1J and 0.05J to combine those like terms. You need to make sure that you add that 1 to the 0 that is a whole number. Do not add it to the 5, which is in the hundredths place. This is a whole number 1 in front of our J here. So it actually is going to be 1 and 5/100 J is our simplified expression. Then we're going to take our $35, that is J, and plug it in. So we're going to do 1 and 5/100 times 35, and this is going to give us our answer. So I am going to pull out my handy dandy calculator, and you should do so as well to figure out what that is. So we would clear out our calculator first and then put 1.05 times 35 equals, and I get 36.75 or $36.75. You're ready to do example number 5. However, there is one more, you're ready to do letter F, but there's one more example, example number 5. At a concert, you buy some t-shirts for $12 each and the same number of CDs for $7.50 each. Write an expression in simplest form that represents the total amount spent. So here they're not giving you an expression, you need to write one. So let's go back and figure out how we're going to do that. At a concert, you buy some t-shirts for $12 each. We got to find the facts. T-shirts are $12 each. So I would box that in. And then the same number of CDs are $7.50 each. So We are buying t-shirts and CDs, and we're buying the same number of them. So it says, write an expression in simplest form to represent the total amount spent. So we know how much t-shirts cost. We know how much CDs cost. What we don't know is how many we bought. So that's going to be our variable. And I suggest using X as your variable, since we're not talking about just t-shirts and we're not talking about just CDs. We're talking about both. And it's going to be the number, hashtag, of t-shirts. You can just write T's and CDs. All right. So each t-shirt, X, cost $12. So I can multiply that times 12 to get how much I spend on t-shirts. Plus each CD cost $7.50. So I can multiply $7.50 also times X, since X is also the number of CDs. Then we would need to combine those like terms together in order to get a simplified expression. Remember, 12 is a whole number, so we need to add it to the 7. Don't add it to the 50 cents. So you would end up with $19.50 for each CD and t-shirt together. So one CD and one t-shirt together cost $19.50. So what we're actually doing is adding the cost, $7.50 of a CD, and the cost, $12 of a t-shirt together, and then multiplying it times the number of t-shirts and CDs together that we bought. That is the final example in this lesson. You are now ready to go do the lettered problems.